Hello guys, welcome to Pepcoding, and today we will gonna solve this question: remove last in doubly linked list. So we have already done this question in our previous videos, which was in level 1, remove last in singly linked list, but this is a doubly linked list. So first of all, let me tell you the question statement, and I will explain the question statement. Then after that, we will gonna understand its approach, and at last we will just code it out. So let's get to our open board. So let me give you an example of a doubly linked list. So the difference between, so it is like 14 pointed towards 15, then 16, then 17, then 18. It is something like this. So you can see here that I can access 15 from 14, right? And I can also access 14 from 15. It is possible here, right? The only difference between singly linked list and doubly linked list is that I can access both the elements. So now let's understand what our question wants. So here you can see that remove last. So we want to remove the last element of our linked list, right? So if our linked list looks something like this, input linked list, on our output, we want something like 14, 15, 16, 17, and not 18, because 18 has been deleted. Okay, so now first of all, to understand its approach, we will understand some of the edge cases. So first edge case is when list is empty. List is empty. So we cannot do anything if the list is empty, right? Because we need to remove something, right? And if list is already empty, that means there is nothing. Can you remove anything from nothing? No, it's not possible. So for that, we already have a function which is list is empty exception. Empty exception. Exception. We already have this kind of function. Let me show you. So okay, this is our snippet, and here you can see we have a function which is list is empty exception. So this function will print list is empty when the size of our list is empty, 0, right? So now okay, then the second edge case is when we have only one element, right? When we have only one element in our linked list, at that time we have to do something else. And the third case is when we have more than one element. Now there are three cases, and we will gonna talk about every case part by part. So first is when list is empty, second is when we have only one element, and then the third is when we have more than one element, right? So so now first of all, let's talk about this. First, we already talk about this case. Whenever list is empty, we have a function of list is empty exception, and then we will talk about second part when we have only one element. So for example, think about it. We have an linked list with only one element, which is 14. So right now at present, head is here and tail is also here, right? So if head is here and tail is here, and also this is the first element also, and this is last element also of its own linked list, and we need to remove what? We need to remove last element. So we need to remove this 14 from this linked list. How can we do that? It's a different thing, but for now we have to remove it. So now you can see that if I remove this 14 from this linked list, let me show you, there's nothing left. Linked list become empty, right? So in this example, what I can do is I can take my head and I can take my tail, and I will point them to null. So if I point my head and tail both at null, I have already removed 14. I have removed my node which I needed to remove, right? Then the second case is done. Now we have to talk about third case, which is we have more than one element. So if you can see that my list looks something like this: 17, then 18, and at last 19, right? And we have to remove this 19. We have to remove this 19 from here. How can we do that? So now this is the tail. One thing is this is tail, and I can access 18 from tail of previous. Tail of previous. I can access its 18 because it is pointed towards 18, right? So now what I did is I will make one more pointer previous, and I will point it towards 18. Now there is one thing I need to do. Think about it. If I break this bond, and I make my tail, I grab my tail and I put it here, what I can do? My last element of my list is already removed, right? So this is what I will do now. Okay. So how can we do that? First of all, I take two pointers, which was here and here, right? So I have tail, I have previous, right? So now I need to do what is, first of all, I need to break this bond. So what I can do is previous of next of previous is equal to null, and also I can do tail of previous is equal to null. These two lines can break this bond. These two lines can break this bond. And now the only thing left is to update my tail. So if I make something like tail is equal to previous, I can say that now my new tail will be this. And the 19 is deleted. Right? We have done all the three edge cases of this question. First is when list is empty. When list is empty, we have a function which is list is empty exception. Then the second part is when we only have one element, and then the third part is when we have more than one element, right? So now let's get to the coding part, and I will show you how to code this. So let's see the code, and we have to code here. Let me remove it first. So I have to write my code here. Write your code, right? I have to write my code here. So first of all, I will take care of the first edge case, which was when my list is empty. So for that, I already have a function which is list is empty exception, right? So if this exception got true, I have to return what? I have to return -1. Then the second thing is for my second part, which was to remove for the second two cases, I will make a new function and I will assign that verb to that function. Okay, so I will do it node asterisk node is equal to remove last node and return date of node. It's done. Now let's make our function to do its job, which is pretty easy. So just keep your focus here. So I'll make a public node asterisk remove last node, and here I will make a pointer node which will point to this dot tail, which is pointing to tail. One thing is done. Now I will take care of my first case, which was when the size is 1. So if this size is equal to 1, if the size is 1, what I need to do? I need to make this of head is equal to this of tail is equal to null. I just need to make head. I just need to put my head at null, and I just need to put my tail at null, or I can say null pointer. This is the first case which I have covered. Now for the second case, which was when I have element more than one. I taken previous node pointer which will point to this dot tail to previous. Then previous node, next of previous node will point to null pointer, and at last node of previous is equal to null pointer. Now here my second two statements, which are next of previous node and previous of node, are pointing to null. So these two statements are to break the bond, right? And at last what I need to do is just to update my tail. Previous node. Now I have updated my tail, and last when I removed an element, you know that I also need to update the size and return node. So let's submit this code and see if it's work, if there's any compilation error or something. Yes, there is. So let me check what the error is. It is saying that I have an error at which line? 134, right? So let's check if I have. Okay, so 135. Yes, there is an error. Let me show you. 135. So this is not this dot tail, this is this arrow tail. Now let's run it again. Again there is some error. Let me check. 118. Okay, what is the 118? There is this, right? So let's run this code again once more and accept it. Let's submit this code. So correct answer. So if you understand it, if you like my explanation, please like the video. If you have any query regarding this question, please comment it out and subscribe to our channel. Thank you so much, guys.